Hello, everyone. Hopefully, you're doing well. We're going to continue with chapter one, real number and algebraic expressions. In this section, section 1.3, we're going to take a look on operations on real numbers and order of operations. If you missed our lecture on real numbers, I strongly advise you to watch the previous video because real numbers we already covered. We went over it. We said that real numbers are all rational and irrational numbers. Of course, we also went over natural numbers, whole numbers, and integers, and we told you about another category of numbers that's called complex numbers that we would see in the future. The objectives of these sections is to show you how to add and subtract real numbers, multiply and divide real numbers, simplify expressions containing exponents, find roots of numbers, use the order of operations, and also evaluate algebraic expressions. To add two real numbers with the same sign and the absolute values, add the absolute values and add the numbers. So I think that's where we're gonna start. Everyone knows how to add numbers. Like, if we have 5 plus 2, we know it's 7. If we have negative 6 plus 3, all right, what you need to do, because it's a negative, that will be a little bit different, because for us is negative 6 plus 3 gonna give you negative 3. But if you add negative 5, negative 4, what you need to do is negative 5 plus negative 4. All right. So what you need to do is add these two and keep the sign. So that's what give you negative 9. To add two numbers with different signs, subtract the smaller absolute value from the larger absolute value and attach the sign of the number with the larger absolute value. Let's see this in an example very quick because learning by examples, that's what we do most in mathematics. Look at the part A. Negative 14 plus negative 9. Negative 14 plus negative 9, what you need to do is to add the absolute values. For what we mean by that, we take negative 14, we do negative 14 like this, okay, and then we take, we know negative 14 plus negative 9, that would be 14 plus 9, that's 23. But except because there was a negative for both of them, both signs are negative, answer would be negative, okay? So that's mostly what we need to do. If we see for 11, if you take the absolute value of 11, is 12, is 11. I mean, absolute value of negative 11 is 11. Absolute value of 18 is positive 18. So 18 minus 11 is 7, okay? So we can do it this way. So 18 has the larger absolute value and its sign is an understood plus. So the sum is positive. So what we're gonna do, we know this one. If you want to rewrite it, you can rewrite 18 minus 11. That would give you 7, right? So you can switch if you want. But for this one, as you can see, 8 plus 13 is 8 plus 13 is 8 plus 13 would give you plus negative 13. It's the same thing saying 8 minus 13. Now you subtract and keep the sign of the largest number. When you subtract, you can do 13 minus 8 is 5. It's like you said 13 minus 8 is 5. But because the 13 is the larger number and the sign is negative, the answer would be negative 5. Okay. Very quick, those are a few examples you can definitely use. If you go with the next examples, like, you add and keep the sign of the largest number, or you subtract and keep the sign of the largest number. For example, negative 21 plus 12, you subtract because two different signs. Same sign, you add and keep the sign. Different sign, you subtract and keep the sign of the largest number. For example, negative 21 plus 12 is 9. Is it positive 9 or negative 9? It's negative 9 because 21 is the largest number. However, here, 22 minus 9, because 22 is larger, we subtract and keep the sign of the largest number. But 0 has no impact on addition or subtraction. So 0 plus, remember, 2 sign, that's negative, so that gives you negative 12. It's simply negative 12 because we add or we subtract 0 minus 12 is 12, but keeping the sign, okay? Now, the last one, first of all, you need to have the same denominator. So that's the first thing to do. To have the same denominator, you need to do the greatest common factor, the least common multiples. What can divide 5 and 3 at the same times is, yes, 15. So we're going to multiply this one by 3, multiply by 5, by 5. So we end up having 4 times 3 is 12 over 15. 2 times 5, there's a negative. 2 times 5 is 10 over 15. Now, when you have a fraction adding to another fractions, when the denominators are the same, we add or subtract the numerators. So we keep the same denominator 15. Now we're gonna have negative 12 plus 10. Now focus only on the numerator. The numerator says negative positive, so it's subtraction. Now you need to subtract and keep the sign of the largest number. What is the largest number here? Is 12. So 12 minus 10 is 2. We keep the negative. That will be 2 over 15. Remember, in addition, you don't add the denominators. You need to keep the denominator and only perform your operation on the numerators. When you have the same sign, you add and keep the sign. When you have opposite sign, two different signs, you subtract and keep the sign of the largest number. Those are very quick examples we wanted to do. But in terms of subtracting real numbers, what you need to remember in this, if A and B are real numbers, then the difference of A and B can be written A minus B. All right. So like if you said the difference between 17 and 8, all right, so that means it's 17 minus 8, that gives you 9. Okay, so that's what we call the difference. Now, if they ask us to subtract, you see here is all they need to do is really subtract and keep the sign of the largest number. It's like you do 6 minus 10 is like 10 minus 6 is 4, but because 10 is greater with the negative sign, we do this way. If we see when you have the same sign, negative 40, negative 9, because it is the same sign, what you need to do, you add and keep the sign. The sign is negative. We're gonna keep the sign negative and it gives us negative 33 when we add it. Now, we need to perform an operation. I think it's very important to remember sign. When you are in terms of multiplication, if you have an addition times another additions that give you plus, if you have a subtraction times an addition that give you minus, if you have a addition times a subtraction that give you minus, but if you have negative times another negative, that give you positive. That's really important to remember, because here we have parentheses mean multiplication, so these two negative become positive. For us, is that we have negative 12 plus 6. You subtract and keep the sign of the largest number. It's like you do 12 minus 6 is 6. 12 is negative and it's larger, so it's negative 6. 9 minus 6 is 3, because 9 is larger. We have negative 3. 14, negative 14, negative 5. Remember, if you have the same sign, you add and keep the sign. You have the same sign, you add and keep the sign. So that gives you 14 plus 5 is 19. Look at this one, says the same. These two negative become positive. So we have negative 3 plus 4. You see that change? That change to plus 4. And we subtract and keep the sign of the largest number. So that 4 minus 3 is positive 1. Here, again, two negative become positive. So if we have 6.9 plus 1.8, same sign, we add and keep the sign. We rarely write the plus sign in front of a number, right? So if you have only one real number, but if you have like plus 2 plus 5, you must put the plus 5. But if you have only 5, you don't need to say plus 5, right? We know it's plus already. So for this one, it's gonna give us, I don't know if I did it, it is supposed to be 8.7. Now, when you will look at the fractions again, you need to work around fractions to understand it. Remember, we said if you have two negative become positive. All right, negative become positive. We have 3/4. Now this one is plus 4 over 5. Now the problem, we cannot just add the numerators or subtract the numerators, because the denominators are different. So what number can divide 4 and 5 at the same time? So we know 8 divide 4 but doesn't divide 5, 10 divide 5 doesn't divide 4, 12 divide 5, 4 doesn't divide 5, 15 divide 5 doesn't divide 4, and 16 divide 4, no 5. So the first number that can divide both is 20. So we can say that 20 is the least common multiple. We multiply by 5, we multiply by 5, we multiply by 4, and we multiply by 4. Okay, we'll have time to do a lot of this. 3 times 5 is negative 15 over 20. 4 times 4 is 16 over 20. Remember, we said if denominator is the same, we can just add the numerator. So you end up having only 1 over 20, right? Plenty of examples, that's mostly on real numbers. Now, we don't only have one. You cannot do all 3 at the same times. What you need to do is really going over the first 2. We can do any 2 together, right? If you want, you can do the first 2, like 12 minus 5 is 7. Now you have another 7. If you want to do it this way, okay, you can do one by one. So 7 minus 7 is 0. Or if you want, you can do these 2. All right, remember these 2 give you negative 12. Add and keep the sign. So 12 minus 12 still give you 0. All right. I know many of you would use your calculator, but understand the basic operations without using your calculator is important as we move forward and we're gonna do more exercises, okay? That's very important. So now let's see these examples. First of all, as I said, if you have a plus and a minus, probably doing this would be nice. Remember, this one gives you only 9 minus 6 is 3. These two signs become positive. We're gonna have because this one become positive 3 plus 8. So now we have 3 plus 3 plus 8. 3 plus 3 is 6 plus 8. That gives us 14. Of course, we could just go faster on this one, but let you enjoy it this way. It's also important. For this one, we have we can do same sign. We add and keep the sign. So 14, that would be negative 14 plus 11. 2 negative in multiplication become positive, so plus 7. You see, the first two negatives are not multiplication. Negative 9, negative 5 is additions, right? That's why we say it's 14, but with negative sign. But with a parenthesis, a negative outside of a parenthesis, you must multiply it with the sign inside of the parenthesis. So that's why we do that. So we're gonna have, let's say, if you want to do negative 4 plus 11, that gives you, we subtract and keep the sign with the largest number. 11 minus 4 is 7 plus 7, that gives you 14. Okay. Let's see, that gives you negative 14. Oh, negative 14. Sorry, I think I messed up on this one. Let's say we said this one is negative 14. Negative 14 plus 11, that's what we said. Negative 14 plus 11 give you only negative 3. Subtract and keep the sign of the largest number. 14 minus 11 is 3, but 14 is negative. Then the result is negative plus 7 again. 7 minus 3 is 4. Okay? All right, so that's how you add and subtract real numbers. Remember, our goal here is to do as many as possible, but how about multiplying and dividing real numbers? We just add and subtract. For multiplying and dividing real numbers, the product of two numbers with the same sign is positive. So I think that's what I told you before. I said product of two. I mean, when you have a same sign, in a positive number times a positive number give you a positive number. A negative number times another negative number give you a positive number. And the product of two numbers with different sign is negative. That means if you have a negative number times a positive number, it's negative. A positive number times a negative number is negative, all right? We said product property of 0, any number times 0 is equal to 0. Any real number times 0 is equal to 0. So if I do 5 times 0 is 0. 167 times 0 is 0. 0 times 11 is 0. All right, so it doesn't matter. You remember you can put 2 times 3, 3 times 2 is the same thing. Now you see two different signs, negative 3 times positive 8. The answer would be negative. 2 negative become positive. 0 times any number, of course, now you're not gonna say it's negative 0. 0 is really neutral. 0 times negative 50 is simply 0 that you can see over there. Now, two different numbers, positive 10 times negative 5, answer is negative. Okay. Of course, we can do more example of these where we can cover the fractions. Now, what's the rules about fractions? The fraction says if you have a fraction times another fractions, you need to multiply the top together, the numerator with the numerator, and the denominator with the denominator, then you simplify, okay? So that's important. It's different when you do when you add or subtract fractions. When you add or subtract fractions, you need to find the least common denominator. Then same denominator, you add the numerators. But with the multiplication, you must multiply the bottoms together and the tops together. But -1, it's like you have -5 times 1 over 6 times 4. So that gives you -5 times 1 is -5. 6 times 4 is 24. Of course, always check if you can simplify. If you have parentheses, parentheses simply means multiplication. So you do 6 times -2.3. Here we want to know if the answer is positive or negative. Negative. 6 times 3 is 18. Remainder 1. 6 times 2 is 12 plus 1 is 13. So it's going to be 13.8. Okay? Now remember, it doesn't mean you're going to multiply only two real numbers. You can multiply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100,000 of numbers together. But you can do it one by one, like you do 5 times 0 is 0 times -3. Any number multiplied by 0 is 0. You can do the first two together. We know these two become positive. -1 times -6 give you only +6 times -7. Okay, we can do it step by step. That gives you -42. Remember, two different signs. Answer is negative. That's the rules for multiplication. When you have a fractions times another fractions, you multiply the numerators together and you multiply the denominators together. After that, you simplify. How about divisions? For divisions, the quotient of two numbers with the same sign is a positive. It's the same rules like we do for multiplication. So if you have a positive number divided by another positive number, answer would be positive. If you have a negative number divided by another negative number, answer would be positive. But if you have a negative number divided by a positive, answer negative. If you have a positive divided by a negative, answer is negative, all right? Let's see some examples to better understand what we mean. Here, positive, negative, we know 7, 42 divided by 7 would be simply a negative number. Here, we can say it's the same thing writing -16 over -2. It's a different way of writing divisions. 2 negative become positive, 8. Okay. Now we can simplify if we want. 2 negative become, one negative, one positive become negative. 80 divided by 10 is -8. 0, that's very important property to remember. 0 over any number where that number is not 0 is 0. But any number over 0 where that number is not 0 is undefined. So 0 over 7 is, we cannot say -0, so it's simply 0. 8 over 0 is, thank you, is undefined. Do you know why? It's undivided because there is no number that gives a product of 8 when multiplied by 0. That's very important to remember, all right? But we're gonna do some more examples with fractions. Now, the rule says if you have a fraction divided by another fraction, a fraction divided by another fraction, you keep the first fraction as is, you multiply by the reciprocal of the second fractions, okay? For example, here, I'm going to keep my 5/9 and multiply by 3/2. Remember now, we go back when we have a fraction divided times another fraction. What we do again? We multiply the top and multiply the bottom. So we're going to have -5 times 3/9 times 2. So we have -15/18. Do you have any, in this case, do you have any common factor between 15 and 18? Yes, 3. When you divide this one by 3, you get 5. When you divide this one by 3, you get 6. So that would be -5/6. Last examples for divisions, very important. Divisions, again, here, remember we have -2/7 times -5/1. So remember, when you have in divisions, the same sign, both if both of them plus, then it's positive. If both of them negative, minus, they are still positive. So we can rewrite as -2 times -5/7 times 1. So this one would give you +10 because 2 negative give you positive in multiplication. Always double check your final answer to see if it can be simplified, because your answer when you deal with fractions must be presented in the lowest term, all right? So you need in the simplified form. That's very important. Now, exponents, simplified expressions containing exponents is something probably you saw before. Exponents that are natural numbers, shorthand notation for repeating factors. Let's say, remember, if we have 2^3, it's not 2 times 3, it's 2 times 2 times 2. It's the same factor repeated 3 times. 3 power, that gives you 8. If you have 3^4, it's 3 times 3, 9 times 3, 27 times 3, 81. So the base is, if you have a power n, that means you need to multiply the base n times. Okay? But because I don't know what n is, we're gonna go to n. And the exponents, the exponent is whatever you have up there. So not by the order of operation that exponents are calculated before other operations. I don't want to go over there now because I know what to expect in the next sections. If a is a real number and n is a natural number, then the nth power of a, or a raised to the nth power, written as a power n, is the product of n factors, each of which is a. All right, so if we have 5^3, all we need to do is 5 times 5 times 5. 5 is the base, and 3 is the exponent. So that gives you 125 when you multiply them. So very few examples that you can see. We see with the -2 times -2 times -2 times -2. The first thing I can do is count the number of negative sign. If number of negative sign is even, I know the answer would be positive. If the number of negative sign is odd, I know the answer would be negative. Look at that. If I do these two negative, -2 times -2, this become +4. Okay. If I do these two negative, -2 times -2 give you another +4. So you see, 4 times 4 is 16. Okay, but I can count 4 negative sign, that means even, answer positive. Now, but with the second one, you really need to be careful because there is a big difference when you have -8 power 2. -8 power 2, that means it's -8 times -8, right? So you see that give you +64 because 2 negative. But for this one, it is like, you can rewrite it like this one. Okay, that's two different ones. So the negative is outside, it's like you have 8 times 8. So that gives you -64. 3 power 4 is 3 times 3 times 3 times 3. That gives you 81. And oh, I just talked about it like this. You can see, putting the parentheses, make it 2 negative sign. In this case, it's +25 when you multiply them. Again, here there is a negative. You know, it's just doing some extra. Doing extra means you do -6 power 2. That would be -6 times 6 is -36. And when we have fractions, look at that. You have 2/3 times 2/3 times 2/3. That's multiplication of fractions. When you have multiplication of fractions, multiply the numerators together and multiply the denominators together. So that gives you 8/27 that you cannot simplify. We have some other concept to cover, like find square roots of numbers, and also going over the order of operations. We said that opposite of squaring a number is taking the square roots of a number. A number B is the square root of a number A if B squared equal A. For example, square roots of 9 equal 3 because 3 times 3 is 9, all right? Or we can say 3 squared is 9. In order to find square roots of A, you need a number that when squared is equal to that number. But of course, that's why we have calculator for. I know we're gonna cover a lot of examples later about square root, because there is a chapter just on this. But a number that you can raise to power 2 to obtain 16 is 4. 4 squared is 16. Now, I'm gonna go very slowly on this one, because we said if we have square roots of A over B, that's what we'll cover later. We can split it as square root of A over square roots of B. Okay. Now we can say, oh, what should raise to power to obtain 1/36? Or you can rewrite it as square root of 1 over square root of 36. Square root of 1 is what? Is 1. 1 power 1 is 1. But what you raise to power to obtain 36? Is 6. 6 power 2 is 6 times 6 is 36. Now, cube roots. I think you learn a lot about square roots, but you don't only have square roots. That's why in the slide over here, I didn't say that we're going to do square roots. We said roots, okay? So saying roots means it can be any. Here we have cube roots. Cube roots is like what number you raise to power 3 to obtain 27? Yes, 3. Because 3 times 3 times 3 is 27. Now, the same, what number you raise to power 4 to obtain 16? Yes, 2. Because 2 power 4 is 2 times 2 times 2 times 2 equal 16. That's how we do it. That's how we do it. Since 2 is a positive, it's positive, and 2 power 4 is 16, then I think we are on the right track. Now, order of operations, very important. You know, if you do order of operations, simplify expressions using the order operation, it's very important to do PEMDAS, all right? So we said PEMDAS, P stand for parentheses. So you do everything in parentheses first, then you do the exponents. Then you do the multiplication from left to right, because you can do multiplication or you do division. So it doesn't matter as long as you find multiplication first, then you do multiplication first. If you find division first, you do division first, all right? But you cannot do addition or subtraction before division and multiplication when it's involved, when you find them in kind of a product, okay? So that's very important. Subtraction. So that's what we call PEMDAS. So if grouping symbols such as parentheses are present, simplify expressions written those first. Starting with the inner set, if fraction bars are present, simplify the numerator and denominator separately. Evaluate exponential expressions, roots, and absolute value in order from left to right. Multiply or divide in order from left to right. Add or subtract in order from left to right. So we call that PEMDAS. So remember, PEMDAS. P for parentheses, E for exponent, M for multiplication from left to right, D for division from left to right, A for addition from left to right, S for subtraction from left to right. So that's very important. We do it this way, okay? We're gonna go over these few examples. First of all, we see exponent. We must do exponent first. So we're gonna do 6 divided by 3 plus 25. Now we're not gonna do 3 plus 25 because there is a division. 6 divided by 3 is 2. 2 plus 25 is 27. I think we can look at it this way. When you look at the next one, again, we have a parenthesis. First of all, we keep the 2. We know 5 times is a multiplication, but we're not gonna do it. We need to complete the inside first. 2 minus 6, 2 different signs, subtract and keep the sign of the largest number. That would be -4 power 2. Now, again, we're not gonna do 2 plus 5 because addition's not counted first. We could do 5 times -4, but unfortunately, there is an exponent. We need to solve the exponent first. So we keep our 2, we keep our 5. -4 times -4, because it's squared, is positive 16. So we're gonna have positive 16. Again, here we're not gonna do 2 plus 5, but we can do 5 times 16. So 2 plus 5 times What 5 times 16 is? Yes, 80. So our answer is 82. Okay. All right. Let's move forward with our next examples. We have plenty of examples like this that we need to do. The next one here, you can see the 6 plus 9 divided by 3 is what? 3. Do not do 6 plus 9. 3 power 2 is what? It's 3 times 3, yes, it's 9. So now you cannot say I'm going to do the division first. You don't have a division yet because you don't have 6 divided by 9. You have 6 plus 3. You could use a parenthesis here to explain it. Okay, so what we need to do is really to add the top first. That's 9 over 9 is 1. Okay. Let's look at this one. D as in dog. We know the 1 stay. And after the 1, we have a 2, but we need to deal with the inside of the parenthesis first. What the inside says, we have a 5 times. You know what? I am going to use a different slide for that, okay? Let's do, I copy, paste, I erase all of this. Okay, give me just a few seconds. Okay, voila. For this one, what we're gonna do is, we're gonna keep the 1 plus the 2 outside. Order of operation, do everything inside and start from the all the way the inside. So because we see 2 times 3, that makes it 6 plus 1. That's the first parenthesis. I don't subtract anything yet. Then we still have 1 plus 2 times 5. 6 plus 1 is 7 minus 10. Now we're gonna have 1 plus 2 times 5 times 7 is 35 minus 10. Now we still cannot add the 1 plus 2. We cannot add that, okay? So that gives us 1 plus 2 times 35 minus 10 is 25, right? So 25. Okay, we cannot do 1 plus 2. We need to do 1 plus 2 times 25 is 50. So answer is 51. If we take the next example the same, remember this one, if we consider here, it was E as an Edward. Yeah, I know this one can be more complicated. First of all, we have a -5 outside. Square roots of 30 minus 5 give you square roots of 25 plus -2. Remember, if you have -2 times -2, that gives you +4 plus 4 over 4 square. 4 times 4 is 16 plus absolute value of 7 minus 10. 2 different signs, subtract and keep the sign of the largest number. 7 minus 10 is -3. So we have -5 times 5 Okay, remember that's a parenthesis here if we want, plus 4 over 16. Absolute value of any negative number is positive, okay? So, negative 25 plus 4 over 19. Negative 25 plus 4 is negative 21 over 19. Now, we only need to pay attention if we can simplify. There is no common factor between 21 and 19 because 19 is a prime number. We're going to have a chance to talk about it later. All right. Now, some expressions, when you evaluate algebraic expressions, remember we said you can have so many like this that they're going to ask you. Sorry about the noise. Evaluate, because we know what is z here. We can substitute 7 plus 3 times negative 3 because they said z is negative 3. First of all, you need to remember your order of operation and the sign also. That's why we need to keep it that way. Okay. Now, x and y are given. You can substitute them in the original expressions. All you need to do here is, so 4 times 4 is 16. But now if you have negative 5 times negative 5 give you positive 25. So a positive 25 at this point plus 16 give you 41. Okay. One or two more examples to finish, to complete it. If they ask you to evaluate these expressions where they give you x and y, not all the times you're gonna have both. For example, in example A, we don't have x, so we would only simplify for y square. So that's give you negative 3 times 16, and negative 3 times 16 is negative 48. But in this case, because I have the square roots of x, that means square root of 9 over negative 4 plus negative 4 over 9. We substitute, just replace, and that's it. Replace, that's it. So square root of 9 gives you 3 over negative 4. 1 negative, 1 positive give you negative 4 over 9. It's addition or subtraction. You must find the least common multiple. What number divide 4 and 9 at the same times? Think. 16, 18. For 9 is 9, 18, 27 doesn't divide. You remember 27 doesn't divide 4. 36 is the closest one. So to find 36, we know 9 times 4 is 36. And then we have 4 times 9 is 36. So we're going to have 18 over negative 36, or we're going to say negative up there. Let's put the negative in the numerator because it doesn't matter. And we have negative 16 over 36. Adding negative 3 times 9. Oh my God. Took the red line, right? So that would be 27. So 2 negative, remember, we keep the denominator and add the numerators. And that should give you 6 plus 7 is 3. All right, that's negative 43 over 36. That cannot be simplified. I think that's it. We're doing awesomely awesome with this video, and in another video, we would come back to complete this chapter where we would go over some properties of real numbers and algebraic expressions. Let me know if you have any questions, and don't forget to complete all the required assignments. Take care.